Good morning, students. In our previous class, we discussed about the atomic models like mainly J.J. Thomson's atomic model as well as Rutherford's atomic model. Regarding the postulates of Rutherford's atomic model, we discussed about the main experiment as well as merits, as well as even we discussed about the demerits also. Now, let us solve two simple numericals based on the radius of the nucleus as well as the radius of the atom. So note down the question. Assuming the nucleus of fluorine atom, assuming the nucleus of fluorine atom is spherical, as everyone knows that the nucleus of any of the atom is spherical in shape. Assuming the nucleus of the fluorine atom is spherical with radius 5 into 10 to the power minus 13 centimeter. Okay, the radius of the fluorine atom was given. Now the question is calculate the density of the nucleus. Calculate the density of the nucleus. Okay? So radius of the atom was given and asking to calculate density of the nucleus. Okay? So this was a previously asked question in the competitive exams. And it is based on simple mathematical knowledge. Okay? Even regarding the mass of the fluorine atom, a minimal chemistry knowledge is there. Okay? So don't worry about the question. So first let us write what data they given. The given data radius is given as 5 into 10 to the power minus 13 centimeter. Okay? So what they are asking us to calculate first of all. If you observe there, they are asking us to calculate density. How to calculate the density? As we all know, density is nothing but mass by volume. Right? So density of the nucleus nothing but about mass of the nucleus divided by volume of the nucleus. Okay? For any substance, how we calculate density means density is nothing but mass by volume. So coming to the nucleus, if you observe, so density of nucleus, how we will find? Same simple way, mass of nucleus divided by volume of the nucleus. Okay? Because anyway density means mass by volume. Now regarding this calculation of density, so first we need to know mass as well as the volume of the nucleus. Now first of all, radius we know, so from that we can get volume. What is the formula to find volume of the sphere? Because anyway nucleus is in the spherical shape. So how to find the volume of the sphere? We know 4/3 pi r cube. Now coming to that. Volume of nucleus. It is 4/3 pi r cube. Okay? It is not only for nucleus or not only for atom. For any spherical one, generally we learn in mathematics that the volume of the sphere is 4 by 3 pi r cube. So anyway, these are constants. Coming to the r, the value they already given. Let us substitute the formula. 4 by 3 pi value we all know it is at 22 by 7, nothing but 3.14. Radius how much they given? 5 into 10 to the power minus 13 r cube. So I have taken the power cube. Therefore write the values there. So 4 by 3 into 3.14, 5 cube. 5 square means 25. 5 cube. So 5 into 25. How much it is? 125 into 10 to the power minus 13 whole cube. Okay? How will you find that one? 10 to the power minus 13 whole cube. We all know that x power a whole power b is equals to x power a into b. Right? So it is nothing but 10 to the power minus 13 into 3. So 3 13s are 39. Okay? So it is 10 to the power minus 39. Okay? So if you observe the calculations, 3 will be cancelled in 3.14, just more than 1 time. Okay? Got it or not? So 4 into 125, exactly if you do, you will get around 500. But into more than 1, so answer will be more than 500. So approximately I am taking it as 524 into 10 to the power minus 13. And in a simple manner, 5.24 into 10 to the power minus 37. This is the volume of the nucleus. Okay? As it is given in centimeters, so volume units, because radius is given in centimeter, r cube we have taken, so units of that volume will be centimeter cube. Okay? So what is the other information we needed here? Mass of the nucleus. Okay? What about the mass? What is the atomic weight of fluorine? Coming to the density calculation. Mass of nucleus. Nucleus nothing but we know electrons mass anyway neglected. The atomic weight of fluorine is 19. Okay? But that 19 is AMU. So we need to convert that AMU in terms of density, grams. So 1 AMU is nothing but 1.66 into 10 to the power minus 24 grams. Volume how much we got? 5.25 into 10 to the power minus 37 we got. Okay? 5.24 into 10 to the power minus 37. So this is in terms of grams, this is in terms of centimeter cube. So as we all know, density units will be what? Gram per centimeter cube. Coming to the calculations. 10 to the power minus 37 when comes to the numerator, it will become 10 to the power plus 37. Okay? Then 10 to the power 37 minus 24. So it is nothing but 10 to the power 13. Right? Understood, Amma? When 10 to the power minus 37 comes to the numerator, it will become 10 to the power plus 37. But powers, if you add, because bases are same, 37 minus 24. So it is 13. Okay? Plus 13. Now coming to the calculation point of view. How many times it will be cancelled here? Nearly if you do the calculations, 5 will be cancelled in 19 will be around 4 times. But 5.24 will be cancelled less than 4 times. Because 4 5s are 20, it will be cancelled here less than 4 times. Okay? Here we have more than 1.5. So 4 into 1.5 you do, it will be approximately 6. So our answer will be around 6 point something or 6.2 or 6.02 will come approximately. So 6 into 10 to the power 13 gram per centimeter cube. Okay. So finally, density of nucleus is equals to 6 into 10 to the power 13 units what? Gram per centimeter cube. Okay. This multiplications and divisions I know you are able to do. Why I am not doing exact calculations? We know for exact calculation it will take too much time. Okay. Simple multiplication division if you do, you will get the approximate answer. Okay. Because our task is to find out of the 4 options which option is correct. Okay. If you have the options like 6 around 6, if you have 2 options, then we should go for exact calculation. Okay. Approximately it will come to know. So 5 normally in 20 it will be cancelled 4 times. But it is 19 and it is 5.24. So it cancels less than 4 times. Okay. Here it is more than 1.5. So there less than 4. Here more than 1.5. So that is why multiplied 4 into 1.5. So we will get approximately 6. Okay. Even if you do exactly, there also you will get nearly the same. Okay. Now, regarding this question, what is the important note we have to remember? One is how to find the volume of the nucleus. Okay, because volume is nucleus is in spherical shape, so its volume formula is 4/3 pi r cube. And one more important point we need to remember is mass. How to find the mass of the nucleus? Because nucleus contains protons and neutrons. So whatever the atomic weight is there, so that will be the mass of the atom. For example, if you take the fluorine, fluorine we know its atomic mass or mass number. If you see, it is a 19 AU. Okay. Atomic mass unit, or we can take 19 grams, but that 19 grams is for 1 mole of fluorine. So divided by Avogadro number we have to do to get the mass of 1 fluorine atom. So by doing Avogadro number in the denominator, the same thing you will get. Remember this, Avogadro number is 3. 1 AM is nothing but 10 to the power minus 24 grams. You note down very clearly in the notes. Okay. Regarding this question, the very important note is 1 AM is nothing but 1.66 into 10 to the power minus 24 grams. Okay. Nothing but nearly the mass of the proton. Anyway, we can remember that value. Because everyone knows this concept, but only the mistake they will do. Mass of the nucleus they will take simply as a 19 grams. Okay. But why we multiply with this number? The 19 grams is for 1 mole of fluorine atoms. But we want the mass of 1 fluorine nucleus. Right? That is why divided by Avogadro's number. Or simply remember that one. To convert the atomic mass unit into grams, we have to multiply it with 1.66 into 10 to the power minus 24 grams. Okay. Then simply density formula, anyway every one of you know the formula, mass by volume. We substituted, we have done the calculation. Right? Note down. Now coming to the next question. It is also based on the radius of or even volume of the nucleus and the atom. Note down one question. A simple question. The radius of nucleus of an atom is 10 to the power minus 13 centimeter, and the radius of the atom is 10 to the power minus 8 centimeter. Then calculate the fraction of volume occupied by the nucleus. Okay, so if you observe the question, there they given radius of atom as well as the radius of the nucleus. Both the values are given. Now they are asking to calculate the fraction of volume occupied by the nucleus. Okay, fraction of volume nothing but what we all know. We have done many numericals previously. How to find the fraction of space occupied by the particular sphere? Volume occupied by the sphere divided by total volume. Okay, so fraction of space occupied by the sphere are nothing but the nucleus. How can we calculate next? Volume occupied by the nucleus divided by total volume of the atom. Okay, so in the previous question we already discussed how to find radius, volume of the sphere using the radius. What is the formula we had? It is volume of the sphere. Formula is 4/3 pi r cube. Now first let us calculate the volume of nucleus. How much they given? First of all, write the formula 4/3 pi r cube. So nothing but 4 by 3 pi. R value how much given now? Radius of the nucleus given as 10 to the power minus 13. Okay. So when you calculate, the value will become 4 by 3 pi into 10 to the power minus 39. Right? 10 to the power minus 13 whole cube. So my 10 to the power minus 39. That is what? Volume of the nucleus. What we need to find next? Volume of the sphere. Now let us calculate volume of the atom. Same formula, because both atom as well as the nucleus both are spherical in shape. So in this case also the same formula. That is why I did not done any calculations regarding 4 by 3 and 5. Let them leave like that. Radius of the atom was given as 10 to the power minus 8 whole cube. So finally we will get 4 by 3 10 to the power minus 8 whole cube. So 3 into 8 24. Okay. So we got volume of the nucleus as well as volume of the sphere. Now let us find fraction of space or volume occupied by nucleus. What is the, how to calculate this fraction means volume of nucleus divided by volume of atom. Volume of nucleus, how much we got? Let us substitute here. 4 by 3 pi into 10 to the power minus 39 divided by volume of the atom, how much? 4 by 3 pi 10 to the power minus 24. Okay? 4 by 3, 4 by 3 as well as a pi gets cancelled each other. What is left then? 10 to the power minus 39 by 10 to the power minus 24. So when you bring it to the top, we have 10 to the power minus 39 by 10 to the power minus 24. So minus 24 when it comes to the numerator, it will become plus 24. So 24 minus 39, nothing but 10 to the power minus 50. So this is the fraction of volume occupied by the nucleus. Okay? Understood the question or not? Volume of, sorry, radius of the atom, radius of the nucleus, both are given, and they are asking to find the fraction of space occupied by nucleus. Okay? For example, based on the same concept, if in the examination if they ask you to find the percentage fraction of volume occupied. Okay? If they mention percentage, what to do? Simply the final one should be multiplied with 100. Okay? Got the point or not? If they ask percentage fraction, then what will come in the formula? The whole into 100. Okay? I think you all know all these things. Once go through this. Generally, these model questions in the NEET level they are not asking, but previously the AIMS level, once they ask, this model is enough. Okay? Simply it is based on the mathematical knowledge of finding the volume of the sphere. Okay? No doubt. Now, till now we discussed about the Rutherford atomic model. Now, next atomic model is what? A very famous, well-known atomic model, Bohr's atomic model. Okay? But before discussing about the Bohr's atomic model directly, we need to know based on what concept Bohr given the atomic model. Okay? Before discussing about the Bohr's atomic model, so first let us focus on the dual nature of electromagnetic radiation, which was successfully explained by Einstein. We know the dual nature of light was explained by Einstein. Maybe you may confuse with the de Broglie. De Broglie explained what? About de Broglie's dual nature of matter. Okay? The dual nature of the matter was explained by de Broglie, but the dual nature of light was explained by Einstein. Everyone knows that light is having wavelength. Okay? But there are some theories based on that they proved that light is having particle nature also. Nothing but light is having dual nature. That was proposed by Einstein. But before discussing about the dual nature of light, first let us discuss about particle nature of EMR. EMR means electromagnetic radiation. Okay? Particle nature of electromagnetic radiation. Okay? Because radiation means everyone knows they will have wave properties. We already discussed about the wave properties. Now, on what base we can say these electromagnetic radiation is having particle nature also. Okay. There are mainly two concepts which explains this. Out of that, the very first one and the most important one is Max Planck's quantum theory, simply known as Planck's quantum theory. It was proposed by Max Planck. This is the name of the scientist who proposed the quantum theory. You all know. I hope you remembered everything. Let us discuss simply about this Planck's quantum theory. Okay. So, what is the statement given by Max Planck here? The main statement what he is saying is generally we may think that light is a source of energy definitely, and light passes continuously. Means in this manner the radiation of light will be travels. Okay. But coming to the Max Planck, when any substance or any body emits the radiation, emits means it releases the radiation or absorbs the radiation not in a continuous manner. Okay. It don't emit or don't absorb the energy in continuously. Okay. Then without continuously, it is not emitting continuously means it is emitting the radiation discontinuously. Okay. Discontinuously means like this gaps will come. Understood the logic? So instead of continuous flow of this energy, here according to Max Planck, energy is emitted or absorbed from any body in the form of or in a discontinuous manner, in the form of the small energy packets which are named as quanta. Okay. So that is the main statement given by Max Planck. Right? So first note down the statement given by Max Planck. Any body emits or absorbs radiation or simply energy discontinuously. Okay. Any body emits, nothing but releases or gains, absorbs energy discontinuously in the form of discrete energy packets, which are known as, we all know about the name of this one. In the starting heading only we will come to know it is related to the quanta. It is known as quanta. That is why this theory is known as quantum theory. Okay. The small energy packets are known as quanta. Right? If the substance may releases some quantity of energy, okay, but that energy won't be gained in a continuous manner. It will be gained in the form of small energy packets. Those are named as quanta. Okay. Along with this, mention one more important point. That is, the total energy absorbed or emitted from the body is an integral multiple of this quanta. Okay. the energy emitted or absorbed from the body, by the body is integral multiple of quanta. The energy of the quanta is nothing but generally represented as a h mu. Okay, integral multiple means what? It may be 1, 2, 3. So quantity of energy whatever is released is an integral multiple of h mu. So that is why we will write in the formula as n into h mu. Okay, so their integral multiple is nothing but n number. How much is the n number? It is a integer. 1, 2, 3, so on. Okay. So this is the main statement we need to remember regarding the Planck's quantum theory. Then I will give the mathematical relationship related to Planck's quantum theory. Now, let us discuss about the mathematical relationship regarding the statement given by Planck's, okay, in the quantum theory. Here, according to him, the main relationship we need to remember is that E is equals to E nothing but energy of the radiation is equals to N into H mu. This is the main relationship we need to remember. Okay. So regarding this relation or regarding any formula, first basic thing we need to know what are the terms involved in this. Okay. Where capital E is nothing but energy of the or energy of radiation. Okay, where capital E means energy of radiation. Where mu means what? We all know mu means frequency of the radiation. Okay. Now here comes the door. What is meant by n? We all know that in the last statement we discussed, the amount of energy is an integral multiple of h mu. So n is an integer whose values will be from 1, 2, 3, 4, so on. Okay? N is an integer whose values are from 1, 2, 3, 4, so on. Then what is this h? We all know the value of h also, where h is known as what? We all know already, we have solved many times. H means Planck's constant. We should remember the value of Planck's constant. How much is the value of Planck's constant? Its value is 6.626 into 10 to the power minus 34 joule second. Okay? The value of Planck's constant is 6.626 into 10 to the power minus 34 joule second. In terms of Ergs, its value is 6.626 into 10 to the power minus 27 ergs. Okay? So we need to remember mainly in terms of joules. And if they ask in the examination in terms of ergs, we have to multiply it with 10 to the power 7. Okay? So remember this one first. H is nothing but a Planck's constant. Its value is 6.626 into 10 to the power minus 34 joules. Okay? So these are the main terms involved in the formula. Previously, we all know that mu is nothing but what? Frequency. We already discussed. We can write the frequency in terms of frequency is nothing but what? We can write in terms of wavelength. Mu is nothing but frequency. It can be written in the form of wavelength also, like mu is equals to c by lambda. But what is meant by c? C means what? Velocity of the light. Even we solved numericals also. Now if you substitute this one in the formula, it will become what? E is equals to mhc by lambda. Okay? If they ask the question based on frequency, we should use this formula. If they ask the question in terms of wavelength, then we have to use this one. Okay? It is not a new one. Simply, what is frequency? We substitute. Where is the given one? What is meant by c? C is nothing but velocity of light. Where lambda means, we all know it is nothing but the wavelength of radiation. Okay? Lambda means wavelength, mu is frequency, c is velocity of light. How much is the value of velocity of light? It is 3 into 10 to the power 8 meters per second. Now this is the formula we are using. For example, if you want to find energy for one quantum, one quantum means the value of m is 1. When n value is 1, what is the formula we generally use? E is equals to h mu. Nothing but E is equals to hc by lambda. And even we learned that mu bar means what? Wave number is nothing but the reciprocal of wavelength. So if we use this one, since wave number is 1 by lambda, so above formula we can write it as E is equals to hc mu bar. Okay? Right? So these are the formulas mainly related to the Planck's quantum theory. These are direct questions they are asking. Generally in the KCET exams also, many times they ask you simple direct questions based on this formula. Okay? Either by giving the frequency or wavelength, generally they used to ask to find the energy of the radiation. Okay? Now regarding these formulas, we need to focus on the relation between energy and the radiation and the frequency of the radiation. What formula we have? E is equals to h mu, where h value is a fixed value, right? H is a constant or not. So from this relation, what we can say? E is directly proportional to frequency. Okay? Energy is directly proportional to frequency, because both are in the numerator. H is a constant value, so we can say energy is directly proportional to the frequency. Okay. Now, when energy is directly proportional to frequency, what about wavelength? Because the frequency is inversely proportional to wavelength. Because wavelength is here, energy is in the numerator. Okay? Wavelength is in the denominator. So energy is inversely proportional to wavelength. Okay? So for example, For a given radiation, if frequency is increasing, what about the energy of radiation? Will also be increases. Okay? When energy is increasing, what about the wavelength of radiation? Wavelength of radiation decreases. Okay? So wavelength increasing means energy decreases. Right? If you understand this, now answer one simple question. I hope in the weekend examination you solved this. Then answer this question. Which of the following radiation has highest energy? Okay? Out of the four options, they are asking to find which has highest energy. Yellow light, red, option C, blue, option D, orange. So these are the four different colors given. Now my question is, out of the four, which is having highest energy? Somebody may think that you did not explain the energy of this radiation. No. Previously we discussed about Gibbs-Yor. Okay, in the Gibbs-Yor, that is the increasing order of their wavelength. So, we know about all these in the order of Gibbs-Yor. I hope you remember this one, Gibbs-Yor. Right? This is the increasing order of their wavelength, right? So, and even we discussed also the red colored light radiation is having highest wavelength. Now, the question is what? Which light is having highest energy? Not the wavelength. Okay? So, in what way energy and the wavelength are related? Wavelength and energy are inversely proportional. Okay? So, highest energy means lowest wavelength. Okay? So out of these colors, which color is having lowest wavelength? Violet is having lowest wavelength. Next, indigo. Next, blue color. So out of the four colors, which is having lowest wavelength means blue color is having the lowest wavelength. Nothing but it is having highest energy. Okay? Because this is increasing order of wavelength, nothing but this is in this direction energy will be increases because energy and wavelength are inversely proportional. So out of these four colors if you observe, which is having highest? Blue color, because they did not give violet color in the options. Okay? We have to arrange these four in the increasing order of their wavelength. Then we will come to know blue is having more energy because lowest wavelength than green, yellow, orange and red color. Okay? Like these type of questions many times they ask. Right? So note down this one. Answer for this question is blue color because it is having lowest wavelength. Nothing but having highest energy out of the four given options. Okay? Okay. Now, let's solve some numericals based on Planck's quantum theory. Now coming to the first question. I think we already discussed one question, one theory question. But before discussing about that question, let us note down one formula, okay, regarding this Planck's quantum theory. Just now we came to know that the energy and the wavelength are inversely proportional, right? Now, note down one important one. Not a new formula, right? Whatever the relation we got from that, I am going to derive. I am going to give you a formula which will be useful to solve some type of problems. Okay? This formula we are going to use mainly the relation between energy and the wavelength. For two radiations, when we are going to compare, what happens? E1 by E2 is nothing but lambda 2 by lambda 1. Okay? This is first thing. It is not a new formula. E1 by E2 if you take 1 by lambda 1 divided by 1 by lambda 2. So volta. So it will become lambda 2 by lambda 1. This is one simple thing. Along with that, note down one more useful formula. That is if the wavelength of radiation absorbed is lambda and lambda 1 and lambda 2 are the wavelengths of two emitted radiations. Okay? Observe carefully. Lambda is the wavelength of the radiation which is absorbed. Okay? We all know in the hydrogen spectrum, in the Bohr's atomic model, you may already learn when any element, substance like electron, if you observe, if the particle absorbs energy, it jumps to its higher energy, right? But while it is coming back, it radiates and it emits the energy. Okay? If you observe there, the energy required to jump is exactly same as energy released when it is coming down. Okay? So based on that, nothing but energy emitted during when it is coming down is same as energy absorbed. So based on that concept, if you observe there, energy and wavelength are inversely proportional. So I can say 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. Okay? Right? Because, for example, if the electron, instead of coming directly to the bottom, generally we know it may come to the ground state in stepwise also. Okay? So this is the lambda, wavelength of light, which is absorbed. These are the two radiations, lambda 1 and lambda 2. Okay? Somebody will do the mistake in the examination like by doing lambda is equals to lambda 1 plus lambda 2. We should not do like this. Okay? Because wavelengths won't be equal. Energy will be equal. The total energy absorbed during this jumping will be same the energy released when it is coming to the bottom. Okay? So we should equate the energy. Anyway, energy is inversely proportional to wavelength. So 1 by lambda is equals to 1 by lambda 1 plus 1 1 by lambda 2. And the above one, we can write it like lambda 1 into lambda 2 divided by lambda 1 plus lambda 2. Okay? Right? We have taken LCM, then we have made beta. Now down this one. When we are going to use this formula is used to find by giving wavelength of the absorbed radiation and wavelength of one of the emitted radiation they given, and if they ask you to find wavelength of the second radiation, then this formula will be used. Okay? Now down this formula. Based on this, let us solve some numericals in the next class.